Hello viewers, in today's class we are going to take up an important definite integral related to greatest integer function, right? So here let us find the value of the integral from 1 to 7 over 2 and greatest integer function 2x minus 1, right? So let us first denote this integral by I, and here we see that the lower limit is 1 and the upper limit is b, right? And we see that the value of x, it lies in the interval 1 to 7 over 2. So this can be written as x belongs to 1 comma 7 over 2, right? So when x belongs to this interval, then 2x minus 1, right? Then 2x minus 1 belongs to, see, if we substitute x equal to 1 here, then the value of 2x minus 1 is 2 times 1 minus 1, that is 1. And when x is 7 over 2, then the value of 2x minus 1 is 2 times 7 over 2 minus 1, that is 7 minus 1, 6, right? So when x belongs to this interval, then 2x minus 1 belongs to 1 comma 6, right? Okay, now if we represent this interval as suppose we have a line here, number line, and here we have 1 and here we have 6, right? Then we see that the integers which lie between 1 and 6 are 2, 3, 4 and 5, right? Now our next aim is to express this function, this greatest integer function 2x minus 1, as a piecewise function, right? So we'll split the function into different intervals, right? So what we can write, so we have a 2x minus 1, this is the greatest integer function 2x minus 1. Now here we see that the value of 2x minus 1 lies in the interval 1 comma 6, clear? So if we take the interval 1 to 2, right? So here I am writing the interval, that is when 2x minus 1, it lies between 1 and 2. So we can write 2x minus 1 is greater than or equal to 1 but less than 2, right? Then the second interval, so we'll write the values of greatest integer function 2x minus 1 after we write all the intervals here, clear? Now let us take this interval 2 to 3. So when 2x minus 1, it lies between 2 and 3, we can write here 2 and here we can write 3, clear? Then we have the interval 3 to 4, so we can write 3, and here we have 2x minus 1 less than 4, and when we write 5 to 6, then here we have 4, and here we have 2x minus 1 less than 5, right? Okay, and when we take 5 to 6, then here we have 5 and here we have 2x minus 1 less than 6, clear? So we have written here these 5 intervals. Now from the definition of the greatest integer function, we know that the value of greatest integer function 2x minus 1 is 1, right? When 2x minus 1, it lies between 1 and 2, clear? Because the definition of the greatest integer function is suppose here we have 2x minus 1, right? So when this 2x minus 1, it lies between 1 and 2, then the value of this function is 1, because this is greatest integer less than or equal to 2x minus 1, right? For example, if we take a value between 1 and 2, for example, if I take 1.9, right? So 1.9 will lie somewhere here, right? Then the value of greatest integer 1.9 is equal to 1. So that's why we have written here 1. Similarly, or similar argument goes for this interval also. When 2x minus 1 it lies between 2 and 3, then the value of greatest integer function 2x minus 1 is 2, right? Similarly, here we have 3, here we have 4, and here we have 5. Okay, so now our next aim is to express these inequalities in terms of say x, right? Suppose if we solve this inequality 1 less than or equal to 2x minus 1 but less than 2, and if we solve this inequality for x, clear, then what we will get, let us see. So if I add throughout 1, then here we have 1 plus 1, and here we have 2x, and here we have, because minus 1 and plus 1 get cancelled, or we can write here minus 1 plus 1, and here we have 2 plus 1. Clear? So we are solving these 5 inequalities for x. Clear? So adding throughout 1, so we get 1 plus 1 2, here we have 2x, and here we have 3. Clear? Now dividing throughout by 2, we'll have 1 here, and here we have x, and here we have 3 over 2. Clear? So we have expressed this inequality like this. Clear? So 2x minus 1 when lies between 1 and 2, then x lies between 1 and 3 by 2. So this inequality is equivalent to 1 less than or equal to x and less than 3 by 2. Clear? Similarly, we'll solve these 4 inequalities in terms of x. So here we have the second inequality, 2 less than or equal to 2x minus 1 less than 3, and let us solve it. So adding 1 throughout, so here we have 2 plus 1, here we have 2x minus 1 plus 1, here we have 3 plus 1. So this is 3, and here we have 2x, and here we have 4. Dividing throughout by 2, we have 3 by 2, here we have x, and here we have 2. Clear? So this inequality is equivalent to 3 by 2 less than or equal to x and less than 2. Clear? So similarly, we can solve these 3 inequalities, and let us write these 3 inequalities in terms of x. So now we have expressed this greatest integer function as greatest integer function 2x minus 1 is equal to 1 when x lies between 1 and 3 by 2, right? And this is equal to 2 when x lies between 3 by 2 and 2, and this is 3 when we have x lying between 2 and 5 by 2, and here we have 4 when x lies between 5 by 2 x, and here we have 3, and this is equal to 5 when we have 3 less than or equal to x and less than 7 by 2, right? So in the initial integral we have the limit from 1 to 7 by 2, right? So we have written this function as a piecewise function from 1 to 7 by 2, right? So we have splitted this interval 1 comma 7 by 2 into these 5 intervals, and the intervals are from 1 to 3 by 2, 1 to 3 by 2, then we have 3 by 2 to 2, then we have 2 to 5 by 2, then we have 5 by 2 to 3, and then we have 3 to 7 by 2, right? So we have now 5 integrals, right? 1, 2, 3, 4 and 5, that is from 1 to 7 by 2. So now let us write this integral as a sum of 5 integrals by using the additive property. So now this integral I can be written as the sum of 5 integrals. So here we have 1 to 3 by 2, 1 to 3 by 2, and here we have the greatest integer function 2x minus 1 dx, plus then we have 3 by 2 to 2, greatest integer function 2x minus 1 dx, plus 2 to 5 by 2, 2 to 5 by 2, and here we have the greatest integer function 2x minus 1 dx. Then we have from 5 by 2 to 3, greatest integer function 2x minus 1 dx, plus 3 to 7 by 2, and greatest integer function 2x minus 1 dx, right? So we have 1, 2, 3, 4 and 5 integrals. So let us denote these 5 integrals by say I1 plus I2 plus I3 plus I4 plus I5, right? So this is I1, this is I2, this is I3, this is I4, this is I5. So now let us substitute the value of the greatest integer function 2x minus 1 in all these 5 integrals, right? So the first integral is from 1 to 3 by 2, and when x lies between 1 to 3 by 2, then the value of this greatest integer function is 1. So here we'll have 1 dx, right? Similarly, in the second integral we have 3 by 2 to 2, and the value of this integral is 2. So we have here 2 dx, plus 2 to 5 by 2, and the value of this integral when greatest integer function 2x minus 1 lies between 2 and 5 by 2, and the value is 3. So here we have 3 dx, plus we have from 5 by 2 to 3, and the value of greatest integer function 2x minus 1 is 4. So here we have 4 dx, plus we have 3 to 7 by 2, and the value of 2x minus 1, greatest integer function 2x minus 1 is 5 when x lies between 3 to 7 by 2. So here we have the value as 5 dx. Clear? Now it is a simple task to evaluate these 5 integrals. So here we have 1 dx integral of, so we have simply x, and the limits are from 1 to 3 by 2, and here we have the integral of 2, that is 2x, and the limits are 3 by 2 to 2. Here the integral would be 3x, and the limits are from 2 to 5 by 2, and here we have the integral 4 dx, so this is 4x, and the limits are from 5 by 2 to 3, plus here we have the integral 5 dx, so the value of this integral is 5x, and the limits are from 3 to 7 by 2, right? Okay, so now we can easily find out the values of these 5 expressions. So this is 3 by 2 minus 1. Here we have 2 times 2 minus 3 by 2, plus here we have 3 times 5 by 2 minus 2, and here we have 4 times 3 minus 5 by 2, and here we have 5 times 7 by 2 minus 3. Clear? Now 3 by 2 minus 1 is half, and here we have 2 times, this is 4 minus 3, that is half. Then here we have 3 times 5 minus 4, that is half, and here we have 4 times 6 minus 5, half, and here we have 5 times 7 minus 6, that is half, right? And here we can write half, then 1 plus 2, 1 plus 2 plus 3 plus 4 plus 5, and this is half multiplied 9, 12 and 15, right? So 15 over 2, that is equal to 7.5. Clear? So the value of this definite integral from 1 to 7 over 2, greatest integer function 2x minus 1 dx is equal to 7.5. So this is how we solve this integral.